This is my second progress report where I would like to show you what I have done the last couple of days. Besides a few little things like coloring the output to the console, I did some major refactoring in the backends and some error fixing. A small but very exciting feature is the colored output to the terminal that that just prints, for example, warnings yellow, errors magenta, and critical errors red. So this can be done easily with printf, and I quickly show you how. So this is very simply done by printing a character sequence that allows you to just set the attributes, the foreground color and the background color. It's very simple. You change the color by printing that sequence, then you print your text you would like to have in that color, and then you just print the sequence again for resetting the color to its original. And there you go, you have colored output. Yeah, and the second issue I had was still with the parallel compilation of the shaders in the graphics backends. And I just quickly show you what I mean. In the last report I showed you the scene where this OBJ import just builds up. And this is while all the materials that are involved there in that 3D object are compiled in parallel. So while this thing is rendering, it turned out that there is a lot of synchronization missing, or the parallel access to those data structures in the back end was a problem. So I had to fix that, and that came basically with the development of the demo I'm currently doing. So let's just quickly show that. While developing this demo, the data races, the unsynchronized data races, really started appearing when the scenes are hot loaded. So for example, the rings here is scene 1, and this field of cubes is the second scene. And when I jump to some time point, one scene is not present, so it's not loaded. When I start to play the demo, then here you can see in this color, things are starting to hot load or load into the scene. And while the demo is running, actually all the shaders are compiled and data is accessed. So that access must be synchronized, or the application crashes, and this is what I experienced here. So let's quickly go into that. So for this purpose of synchronization, I developed this data structure where we can just guard the items that are in it. Let me just show you that. So we have the data structure has a list of items where we put all the items the backend needs in. So we have for geometry, shaders, render objects, and whatnot. In order to guard the access to those data properly, I developed this data structure where we put all the data or the particular data in that the backend needs. And here, for example, we have the items we are putting in. That items array is guarded by a multi-reader single writer lock, so that we can assure that only one writer is accessing that items array at a time, and we can have multiple readers in that items array when we need to read it. And the second thing we need is a semaphore to guard the particular item. I did this using a kind of a semaphore using an atomic, but this works basically as follows. If the busy flag is 0, we can enter it. If the busy flag is 1, we cannot. So when we have a write operation, for example, when shaders are compiled, things need to be changed and need to be released, for example, and recreated. So this thing must be 1, so no one else can access it. And if the object is rendered, we can try to access it, and if that fails, we just go on with other objects to render. So this is basically what's happening here. So as you can see, shaders are compiled while the application is running. This next scene is loaded, and as you saw right there, the previous scene was just unloaded, so that we have at any given time we have just one scene in the application that is displayed, and where we can have the data allocated and everything, so that we are not wasting any memory that we actually need for it, and also processing power. And I just show you that we can just open another window, and then it hangs again. Ja, weil irgendwas wieder nicht initialisiert ist. Fertig. So, also. Das, ja, keine Ahnung. And that's it basically for this video. It doesn't seem a lot, but I had to do a lot in the background, and a lot of data needed to be changed and refactored. So that was kind of a lot of work. So this basically took 3 days or so to just change the data types in the backends, and for the D3 and the OpenGL backends. Yeah, and I think there's still some issues. It made everything just a bit more unstable. Yeah, that's just because all the compilation and everything is just not sequentially processed, and now it's it's done in parallel, and while it's compiling you can actually issue more commands and render it and things like that, and then that synchronization becomes a bit complicated, I think. And but I think that will change and be improved in the future. And this, as I said, this demo helps a lot in doing that. And I hope it can, in the very near future, deliver a nice demo here. And I hope you just you liked it and had some insights. I'll see you next time.